Hey guys, my name is Red Simanda and this is our project ParaContracts. Let's first go through the white paper and then we'll go through the proof of concept which I have implemented for the same. Let's first go through the problem statement. So we know that in Polkadot there is one relay chain and different parachains built on top of this relay chain. If you want to deploy a contract, you can only deploy on a single parachain. Now, this can cause some issues. What if there's a bottleneck in that parachain? There'll be inconvenience caused. But what if I tell you that instead of deploying contract on a single parachain, you can deploy it on multiple parachains, more than one parachains, and you can perform whatever transaction you want to perform on any parachain of your choice, whichever is offering you the lowest fees. Let's see how we implemented that. First of all, yes, you can deploy a contract on different parachains, but of course the state will be inconsistent. Let's say there's a count variable on in a counter contract and we have deployed this on parachain A and parachain B, and we want to perform the increment function, and this parachain is offering us less fees, so we perform the increment function here. Now count is equal to 1 here and count is equal to 0 here. There is inconsistency in the state. We don't know which one to consider, which one is to be considered. There is no actually solve this problem by introducing the concept of version. So now, if any contract wants, if you want to perform transaction on any parachain, you will also have to increment the version. So let's say this one was offering less fees, so you will perform the increment. So count is now 1, and the version is 1. So now we know that this one is the latest transaction because this has the highest version. So this one has to be considered. So the issue. Not issue, but one important thing to understand is that whenever you call a contract, the state which you have to consider, you have to read the state of all the contracts and all the other parachains in which you have deployed. So it's not like you can just consider the state of the contract in which you are calling. You have to do a cross chain call. So you can do a cross chain call. You can read the this paper, and for now we have implemented a local bridge, but if we move further with this, we want to implement XEMP, and you can read about this how this cross-check functionality works. We'll discuss quickly the parachain deployment flow. So you don't have to know anything about this. This everything is abstracted, and in a proof of concept we have what this is what we have built. We have built the developer tools. So as a person, as someone who writes Solidity code, you don't have to learn anything about para contracts or anything. You can write a normal Solidity code. We have created a para contract parser. You will pass your code through this, and you will get this para contract code. Now this para contract code, you need to register bridge contract. You need to call this add new parallel contract. All these functions, you don't have to worry about this. Once you have your para contract code, you can use our deployer. So we have a deployer as well, and you can use the deployer. It will ask for some parameters and it will deploy it across. Okay, now I'll quickly show the proof of concept implementation. So first of all, we have two parachains. These parachains are nothing but frontier node templates. So if you don't know what frontier is EVM implementation of substrate nodes for parachains so that you can deploy Solidity codes. These are running, and I have added this to MetaMask. And we also have our the developer tools. So first you will use a ParaContract parser and you will enter a normal Solidity code file name, and it will parse it into a ParaContract which is ready to be deployed by the ParaContract deployer. Now you will pass this parsed contract into the ParaContract deployer. You will pass the parachain RPC URLs. You will pass the bridge addresses corresponding to those parachains, and you will enter a private key for an account which has enough valids for all parachains so that you can deploy these contracts on those parachains. Once you are done with this, you will get the contract addresses for the para contract which you wanted to deploy, and you can see for this also the versioning is enabled and distributed state is enabled. So feel free to use the tool